Problems on complex numbers. So first problem is x plus 1 plus I by 1 minus I in a plus ib form. So already we know that the complex number is of the form a plus ib. So here a is the real part and b is the imaginary part. So we have to express this value in a plus ib form. Okay. So consider the given expression, that is 1 plus I by 1 minus I. So here this expression we have to convert a plus ib form. So that's why we have to see the numerator. This is nothing but 1 minus I. Rationalize this denominator. That means 1 plus I by 1 plus I. Okay. That is we have to write 1 plus I into 1 plus I by 1 minus I into 1 plus I. Okay. Here 1 plus I into 1 plus I means 1 plus I square. That means 1 plus I whole square by, here this is the a minus b into a plus b form. A plus b into a minus b means a square minus b square. So 1 square minus I square. So already we know the form value of I square. This is nothing but minus 1. So we have to write this one. Here 1 plus I whole square means this is a plus b whole square formula. We have to apply the a plus b whole square formula. That means 1 square plus I square plus 2ab. That means 2 into 1 into I means 2I by 1 minus of minus 1. Here I square means minus 1. So 1 square plus I square means minus 1 plus 2I by 1 plus 1 2. That means 1 1 cancel. 2I by 2. Here 2 2 will be cancelled. I. So I is there. So we have to write this I in complex number form. That is nothing but 0 plus 1 into I. Okay. This is the a plus ib form. So we have to write this side into 1. So a plus I into b form. So this is the problem. Thank you for watching. Problem. Find real and imaginary part of the form of the value 4 plus 2I by 1 minus 2I. Okay. This is the another problem. Here we have to find the real and imaginary part. So that means we have to write complex number is of the form a plus ib. Here this a is the real part and this b is the imaginary part. Okay. Real part and imaginary part. So we have to calculate this one. That's why we have to tell, already we know that the denominator is complex number, then we have to multiply the conjugate of that complex number. So 4 plus 2I by 1 minus 2I. Here 1 minus 2I is the denominator. So 1 plus 2I by 1 plus 2I. Okay. This is already also known as the rationalization. So 4 plus 2I into 1 plus 2I by, here a minus b into a plus b. A plus b into a minus b is nothing but a square minus b square. So that is 1 into 1 means 1 square minus 2I whole square. Okay. Here we have to multiply these two values. 4 into 1 4. 4 2s are 8I plus multiply 2I in all values. 2I into 1 2I plus 2I into 2I means 2I whole square. That means 4I square by 1 square means 1 minus 2I whole square means 4I square. Okay. 4 plus 8I plus 2I means 10I plus 4 into I square means minus 1 divided by 1 minus 4 into minus 1. So here plus 4 minus 4 will be cancelled. 10I by 1 minus into minus plus 4. 1 plus 4 means 5. 5 ones are 5 2s are. So 2I is the answer. So we have to write this 2I in complex number form. That means 0 plus I2. Okay, 2I or I2 it's same. So here real part is 0. The imaginary part is 2. Okay, this is the problem. Thank you for watching. Find the modulus of complex number 3 plus 4i by 1 plus 7i. So we have to find the modulus of this complex number. We have to take a name. So that's why we have to take let z. This is a complex number 3 plus 4i by 1 plus 7i. Okay. So modulus means mod z we have to find. Mod z formula is root of a square plus b square. Okay. So that's why we have to take modulus. Mod z is equal to, so already we have to write z is this value 3 plus 4i by 1 plus 7i. So we know that the properties of modulus, that means mod z1 by z2 is equal to mod z1 by mod z2. This is the property of this complex numbers. Okay, so that's why we have to write mod 3 plus 4i by modulus of 1 plus 7i. Okay, here we have to write this is the one complex number, this is the modulus of a complex number, and this is another complex number. So already we know the formula for modulus of the complex numbers, that is root of x square plus y square. Here x is 3 and y is 4, that means 3 square plus 4 square divided by, this is also complex numbers, we have to find the complex number. Modulus of the complex number is root of x square minus x square plus y square. So here x means 1, y means 7, that means 1 square plus 7 square. So we have to write this is 3 square plus 4 square means 9 plus 16 by root of 1 plus 49, that equal to root 25 by root 50. Okay, that equal to root 25 means 5. Then we have to write this one 25 twos. Okay, 25 twos means 50. So we have to write 25 twos. So root 25 into root 2 we have to write 5 by 5 root 2. Here 5 is cancelled, that is 1 by root 2. This is the value of this complex number. Thank you for watching. Problems on complex numbers. So first problem is x plus 1 plus I by 1 minus I in a plus ib form. So already we know that the complex number is of the form a plus ib. So here a is the real part and b is the imaginary part. So we have to express this value in a plus ib form. Okay. So consider the given expression, that is 1 plus I by 1 minus I. So here this expression we have to convert a plus ib form. So that's why we have to see the numerator. This is nothing but 1 minus I. Rationalize this denominator. That means 1 plus I by 1 plus I. Okay. That is we have to write 1 plus I into 1 plus I by 1 minus I into 1 plus I. Okay. Here 1 plus I into 1 plus I means 1 plus I square. That means 1 plus I whole square by, here this is the a minus b into a plus b form. A plus b into a minus b means a square minus b square. So 1 square minus I square. So already we know the form value of I square. This is nothing but minus 1. So we have to write this one. Here 1 plus I whole square means this is a plus b whole square formula. We have to apply the a plus b whole square formula. That means 1 square plus I square plus 2ab. That means 2 into 1 into I means 2i by 1 minus of minus 1. Here I square means minus 1. So 1 square plus I square means minus 1 plus 2I by 1 plus 1 2. That means 1 cancel. 2I by 2. Here 2 will be cancelled. I. So I is there. So we have to write this I in complex number form. That is nothing but 0 plus 1 into I. Okay. This is the A plus IB form. So we have to write this side into 1. So A plus I into B form. So this is the problem. Thank you for watching. So multiplicative inverse of z is, thus we use direct formula for multiplicative inverse, that is x by x square plus y square minus I into y by x square plus y square. Okay, that here x is the 2 and y is the root of 5. So we have to substitute these values from this formula. So 2 by 2 square means 4 plus root 5 whole square means 5 minus I into y means root 5 by x square means 4 plus root 5 whole square means 5. So that equal to 2 by 9 minus I into root 5 by 9. This is the multiplicative inverse of this particular value. That is 9 by 2 minus root 5 into I. Okay. Thank you for watching. Next problem is find the additive inverse and multiplicative inverse of 9 by 2 minus root 5 into I. So here we have to find additive inverse and we have to find multiplicative inverse. So first of all, additive inverse means this is nothing but minus z, and multiplicative inverse, that is nothing but 1 by z. We have to find that values. First of all, we have to take this one is, we have to take a name, that is z. So we have to take let z is equal to 9 by 2 minus root 5I. First of all, we have to observe this one. This is not a complex number. So this is the denominator containing complex number. So in earlier topics, the denominator contain a complex number. We have to multiply that conjugate and divide that conjugate. Okay. That means we have to multiply and divide the conjugate of a complex number. So then we have to write 9 into 2 plus root 5I by here a minus b into a plus b. This is nothing but a square plus b square. Sorry, a square minus b square. So 2 square minus root 5 into I whole square. Okay. That means 9 into 2 plus root 5I by 2 square means 4 minus root 5 whole square means square root cancel, 5 will be there, and I square means minus 1. Okay. That equal to 9 into 2 plus root 5I by 4 plus 5. So 4 plus 5 is nothing but 9. Okay. So 9 cancel. Then z is equal to 2 plus root 5I. This is the complex number. So we have to change this number into original complex number. So now we can find the additive inverse and multiplicative inverse easily. Okay. So then here z is equal to 2 plus root 5I. We have to find additive inverse first. Additive inverse of z is minus z. Okay. So minus, already we have to write the z value 2 plus root 5 into I, that equal to minus 2 minus root 5 into I. Okay. And the next we have to find multiplicative inverse of z is This is, see another problem. If z is equal to 2 plus 3i, then find z plus z bar and z into z bar. Here z bar is the conjugate of the complex numbers. So first of all we have to take complex number. Given complex number z is equal to 2 plus 3i. We have to write the conjugate of this complex number, that is nothing but z bar. Here z conjugate meaning is to change the sign of imaginary part. Okay. So minus 3i. This is the imaginary part. We have to change this sign from conjugate value. Okay. Now we have to find the z plus z bar. So z plus z bar is equal to, z means 2 plus 3i is the complex number, plus z bar means conjugate of a complex number, 2 minus 3i, plus 3i minus 3i will be cancelled. Then the value is 2 plus 2 is equal to 4. Okay. Next we have to find z into z bar. So multiplication of the conjugate complex number. That means z into z bar is equal to 2 plus 3i into 2 minus 3i. We have to see this one. This is a plus b into a minus b formula. So the formula is a square minus b square. So here 2 square means 4 minus 3i whole square. Okay. So here we have to write 2 square. That equal 2 square means 4 minus 3 square means 9. I square means minus 1. Okay. 4 minus into minus plus. 4 plus 9 is equal to 13. This is the multiplication of conjugate number. Hence prove the problem. Thank you for watching.